Okay, so here we have another example we're going to look at where we're asked to find this current I here. So I think it's pretty obvious what we're going to be doing is some loop analysis here where we have I1 and I2. And then of course the next step we always do here is find the Laplace transform of everything. So we have 3.36 over S. Wait a minute here, I think I might have made a mistake. Yeah, I did make a mistake. It's not that we've done anything wrong yet. It's just that this voltage should not be 3.36. It should be 336 U at T. So we get 336 over S. Makes a big difference in the problem. And then Laplace transforms, this would get me 8.4S, and this would get me 10S, and then we know the resistors don't change. So I'm going to go ahead and write the two loop equations down first, and then we'll go ahead and work on modifying them and everything. So we have a negative 336 over S plus I1 times 8.4S plus 42. I don't know why I wrote it that way. I typically write it the other way. I1 minus I2 equals 0. And I'm going to write the loop 2 equation down now as well, just so that we don't have, because I'm going to have to get rid of the circuit here in a second just to simplify these equations. So loop 2 here would be 10S times I2 plus 48 times I2 plus 42 I2 minus I1 equals 0. Alright, so now we have the two loop equations and we can go ahead and start simplifying them. So if we look at loop 1 here, we'd have 8.4S plus 42 times I1 minus 42 I2, and this would be equal to 336 over S. And believe it or not, I'm going to just leave it like that for now. You might say, well wait, multiply through by the S. Yeah, should multiply through by the S, but my left-hand side is so simple compared to that right-hand side. So let's leave the left-hand side simple for now, and then we'll worry about putting that S in later. Okay? Trust me. Just trust me. It's going to make things much nicer for us. The only time I really think about multiplying through by the S, as I kind of go on off on a tangent, is if I have multiple terms over S. When you just have a single one like this sitting out at the end here, and it's in the constant portion anyway, it's not attached to variables I2 or I1, I just leave it alone. Now if it was attached to variables I1 or I2, I'd probably multiply through by S, but I'm going to just leave it for now. So let's look at equation 2 then. So equation 2, well, if we're just careful here, we'd get minus 42 I2 plus 10S, and then if I do my arithmetic correctly, plus 90, and that's not I2, I already did something wrong. This should be minus 42 I1. This should be I2, and then that's equal to 0. Now we could go ahead and solve one of the equations, like solve this equation for I1 or I2 and do substitution in, but I'm going to go ahead and use Cramer's rule instead. So remember, we have this triangle, which is the determinant, and in this case it'd be the determinant of 8.4S plus 42 negative 42 negative 42 10S plus 90. So that's what we'd have as the determinant there. And then if we do that determinant, we'd have 8.4S plus 42 times 10S plus 90 minus and it's a negative times a negative, so it's just going to be minus 42 squared. Now, you can see here what's nicer is this is just a simple binomial here that we can FOIL out, whereas I had included this term here, I would have an s squared and an s here, which would just make the work a little bit uglier. It's not that this is somehow going to be so much better, but it's going to make things a little bit nicer for us. Alright, so then what do we have here? Well, if my math doesn't fail me, which we always have to double check, right? 84 s squared plus 90 times 8.4, 90 times 8. My calculator, I punched something wrong. Plus 756 s plus 420 s and then 90 times 42 plus 3,780 minus 42 squared, 1764. (84s squared) plus 756 plus 420 is 1176 s minus 17. Whoops, let's actually do the arithmetic here. (2016). Now, remember, we said that it's always nice to have the s squared just have a 1 here. So I'm going to see, can I get lucky and factor out an 84? So let's see what happens. This should be a plus. And I can factor it out there. So, I mean, it doesn't factor out pretty in the sense that there's nice integers, but it factors out nice enough. And I forgot to write my s there. And then if we continue with this, what we can do here is just using the quadratic formula. It doesn't work out to be nice pretty numbers, but we get that this factors to s plus 12.72 to s plus, and let me just do this again here real quickly, times 2. Actually, that's 12.72 isn't right. Just a second. Let me do this again. I'm sorry, it did factor the 12.72 and I finished out here. So 84 times s plus 12.72 plus s plus 1.98. So not necessarily pretty, but it does work. Now, here I'm going to remind us that the numerator would be, then we'd have 8.4s. Well, actually, got to make sure we keep the correct one here. The numerator would be, we replace the first column, so we'd have 336 over s, 0, negative 42, and then 10s plus 90. So this is just going to be 336 times 10s plus 90 over s. Now, I'm not going to do any more multiplication out on that at all, because we're actually in a very good form here. Why are we in a very good form? Well, because what do we have here? We have that, not V out, we're looking at I1. I1 is equal to (336) 10s plus 90 divided by s, whole thing divided by 84 times s plus 12.72 times s plus 1.98. But wait a minute, I can rewrite this. I'm going to do 336 divided by 84. And I get 4 times 10s plus 90 over s plus 12.72, s plus 1.98, which is going to be in the form a over s plus b over s plus 12.72 plus c over s plus 1.98. So now we just have to finish this problem out with partial fraction expansion. And to finish this problem out with partial fraction expansion, of course we would have then that, I'll just leave it as 4 times 10s plus 90 is equal to a times s plus 12.72 times s plus 1.98 plus bs times s plus 1.98 plus c s plus 12.72. S equals 0. 4 times 90 is equal to a times 12.72 times 1.98. So a is equal to 40 times 90 divided by I get 14.3, and then s equals negative 12.72. We'd have 4 times 10 times negative 12.72 plus 90 is equal to b times negative 12.72 times negative 12.72 times 1.98. We get b is equal to 1.09 is equal to b. And I realize I have something written wrong here. This should be negative 12.72 plus 1.98, and it's a little weird how I have it written there. And then finally, we would do s equals negative 1.98. And if we did that, we would get 4 times 10 times negative 1.98 plus 90 is equal to c times 1.98, I'm sorry, negative 1.98 times negative 1.98 plus 12.72. And I made one mistake here. This b is definitely negative. And then we compute that, we get c equals negative 9.65, I believe. Obviously double check all of my arithmetic, but then that means what we'd get here is we would get then finally for my current, we'd have 14.3 minus 1.09 e to the negative 12.72 t minus 9.65 e to the negative, let's see here, negative, what am I doing here? 1.27, right? 1.98, sorry, 1.98 t. This whole thing would be multiplied by u at t. So kind of messy to get to the final answer, but we did get there.